Hey everyone! Today is our last bit of new material, and it is over oxidation and reduction. Now, this is a really important part about any sort of chemistry class and any sort of chemical reactions. Um, and at the heart of oxidation reduction is just movement of electrons. When one thing loses electrons, it releases a lot of energy. When one thing gains a lot of electron or gains an electron, well, then it might require energy to do that. So, oxidation reduction are processes that drive almost everything in a living system, well, in a non-living system, in industrial settings. Um, and so a redox reaction is what we typically talk about. So redox is the combination of oxidation and reduction into one nice simple word, red ox. And a redox reaction is the transfer of electrons. Now, this is not to be confused with an acid-base reaction where we have protons being transferred. So a proton, H plus, going from one thing to another is an example of protons being transferred, whereas electrons, E minus, going from one thing to another is what is the case in a redox reaction. I think that it's helpful to distinguish these two things from one another. Now, in terms of oxidation reduction, well, oxidation, let's go ahead and start out with maybe a definition that you were exposed to if you took a chemistry class or if you, when you were in high school, took like what is it called? IPC, Integrated Physics and Chemistry class. You might have learned about oxidation. You might have also learned about reduction. And oxidation is loss of electrons. Okay. And I know whenever I took chemistry for the first time, we learned oil. Oxidation is loss. The important part there, that L, yeah, it's loss, but loss of what? Loss of electrons. Now, similarly, reduction, R. Reduction is gain of electrons. R, I, G, rig. So that's why some people use oil rig as a nice acronym to remember oxidation is loss and reduction is gain. Another acronym that I think is good is Leo the lion says GER, LEO, loss of electrons is oxidation. Gain of electrons is reduction. I like Leo the lion says GER just because then you're using electron in this definition. You're tightly associating things because oxidation, well, when something gets oxidized or when something is oxidized, it loses electrons. Whereas when something is reduced, it gains electrons. Now, what we'll commonly see whenever something is oxidized is we will see that thing increase its oxidation number. Whenever something gets reduced, we'll see it decrease its oxidation number. Now, the way that I always try to think about oxidation numbers is I will also think about charges. So, is that charge going from 0 to +1, or is it going from +1 to 0, and so on? Now, in what this oxidation actually looks like in a chemical reaction, here what we have is H2 plus O2 yields H2O. Yeah, it is 2H2 plus no O2 yields 2H2O. What's important about this is to understand what are the charges. And when you look at something like H2 and O2, both of these things have a charge of 0. What that means is that H2 and O2, these diatomic gases, they both have a neutral charge. So that means each of the atoms, each of the hydrogens, and each of the oxygens in this have no charge whatsoever. Now, H2O by comparison. Well, there are two hydrogens and there's one oxygen. What are the charges of these? Well, first of all, if I asked you for the charge of oxygen, the common ion that oxygen forms, you could look at the periodic table and you would see, well, oxygen forms a -2 ion. There are two hydrogens. What is the charge of each one of those hydrogens? Each one of those hydrogens has a +1 charge. So two of them gives a charge of +2. Those combined to equal 0. Okay. Now, what that means is that hydrogen here goes from a charge of 0 to +1. Oxygen here goes from a charge of 0 to -2. Now, what I would recommend that you do is you set up and you say, okay, hydrogen first, and I'm just going to use one hydrogen atom, goes from having no charge to now it has a +1 charge. What are we talking about? We're talking about a negatively charged thing, an electron, being added to something. Okay, think about this as an equation. This right here is an equation. H0 to H +1. What are we going to do for placing this negatively charged electron? Is it going to go here or is it going to go here? And before you answer that, let's go ahead and try it out. If we added, oopsies, these two exponents, +1 and -1, if we add those two together, what do we get? And before you answer that, let's go ahead and look at adding the electron to the other side. What is -1 plus 0? That's -1. And so we want to look at the exponents and say, okay, -1 plus 0 equals is +1. That can't be right. So what do we have to do? The best place to put this would be on this side. An electron being added to this. Okay, so now the question is, what is hydrogen? We're reading from the left-hand side to the right-hand side. Is hydrogen being oxidized or being reduced? This side over here, our hydrogen on the reactant side, has no charge. How do we go from here to here? The way that we do that is by losing one electron. So this right here had to lose one electron to become H +1. So what that means is that hydrogen gets oxidized. Now, there's always an instance where someone looks at this and they're like, oh, but what if I went the other way? And I would just say to you, don't do that. The reason is because we read a chemical reaction left to right. We don't read it right to left. We read it left to right. So our starting place is right here, a hydrogen with no charge whatsoever, and we go to this side, a hydrogen with a +1. Okay, now we have some rules for oxidation numbers. Well, an atom in its elemental form has an oxidation number of 0. An example of that would be something like this, H2, O2. Don't mistake this. This is not the same as H2O. This H2, that's a part of a molecule. So H2, when it's just H2 floating around, those have a charge of 0. Another instance where something is in its elemental form would be something like this. Iron. And if I said an atom of iron, what's the charge of that? Well, the charge of an atom of iron is 0. Next up, a monatomic ion has an oxidation number equal to its charge. Okay, So now if I said Fe3 plus, what is the oxidation number on that? Well, it would be 3 plus. That is the difference here is, well, the context. If I wrote a question that said elemental iron, hmm, sorry, elemental iron, that is referencing this right here. If I said an ion of iron, that is referencing that. Now, in a compound, hydrogen has an oxidation number of +1, and oxygen has an oxidation number of -2. In compounds, hydrogen has an oxidation number of +1. Okay, so something like this. That hydrogen is a part of a water molecule. It has a charge of +2. Oxygen is -2. So then H2SO4. What's the charge of this hydrogen? +1. What about these oxygen? -2. Now, a fair question as a follow-up is, well, there's 4 of them. Does that matter? It does. And we're going to get to that in just a moment. Now, the sum of the oxidation numbers of the atoms is 0 for a neutral molecule or equal to the charge of that polyatomic ion. And what I mean by that is if I wrote this, H2SO4, there's a couple of things that I'd like to go through your mind. First of all is, what is the charge of the hydrogen? +1. What about the oxygen? Well, -2. How many oxygen are there? There's 4. So then what is the charge on this overall molecule? It's 0. That is a neutral molecule. Now, this is important because what if I asked you the question, what is the charge of sulfur in this specific compound? Well, that's kind of tough. It's a little tough, but it's kind of just a math problem. What is the charge of hydrogen? That's +1. How many are there? There's 2. So we multiply the charge by the number of them that there are. So hydrogen gives a +2 charge. Sulfur. Ooh, let's come back to that. Oxygen. Oxygen, there's 4 of them, and they each have a charge of -2. So 4 times -2 is -8. Okay, so essentially what we've got here is a math problem. The charges will add up to be 0. I'm putting little lines to indicate, well, what are the charges contributed by the hydrogen? That'll be the first cell here, this first blank. That's +2. What about sulfur? Sulfur, we'll come back to that. Oxygen, -8. So what does sulfur have to be to give us a charge of 0? Let's think about this. If we add +2 to -8, what's that? It's going to be -6. So then what do we have to add to -6 to equal 0? That's right, +6. Okay, so these are the rules that you need to know. I put these on my note card because these are going to be very helpful. Next up, what is the oxidation number? Or so these are questions for kind of application. What's the oxidation number of oxygen in O2? Remember, this is the elemental form, so 0. What is the oxidation number of oxygen in H2O? Okay, oxygen here, each hydrogen is +1, so oxygen is -2. Okay. Being able to identify those oxidizing or those oxidation and reduction numbers or those charges is a very important thing. Now, in addition to oxidation and reduction, we also have things that if something gets oxidized, it is known as a reducing agent. If something gets reduced, it is a reducing. So, sorry, if something, let me rephrase that. So, an oxidizing agent causes oxidation. It gets reduced and it gains electrons. A reducing agent causes reduction, is oxidized, and loses electrons. So, one way that you could look at that is to say, well, if hypothetically atom A goes, I'll just go with a single atom, goes from 0 to -3.
For baseball. When you
0 to -3. What happened? Well, for something to go from no charge to a -3 charge, that means it gained something negative. What is something negative in terms of a subatomic particle? It gained electrons. A gained 3 electrons. So if something gained electrons, it got reduced. Therefore, this is the oxidizing agent. And the opposite is also true.